Welcome to the AKG, CBL, and DCP-555 configuration video. In this video, we will review the steps to configure the AKG CBL 301 microphone for external mute control and how it connects to a BSS DCP-555 digital signal processor. Using the DCP's web interface, we will then review how it can be configured to react to a touch event at the microphone and in turn manipulate the LED colors. The CBL 301 and 201 have 4 modes of operation. The mute, push-to-talk, and push-to-mute modes all make use of an internal mute circuit. When operating the CBL 301 in external mute control mode, the microphone's internal mute circuit is bypassed and the microphone is continuously active. Control signals can then be sent from the microphone to a digital signal processor to enable or disable mutes found within the DSP's configuration. We are now going to prepare the microphone to be connected to a DSP. We will need just a few things. In addition to the microphone digital signal processor, verify you have the following: a cable stripper tool, a T10 screwdriver to remove the microphone grill and change the microphone's mute mode, a small flathead screwdriver to help loosen the braided shield and tighten the screws found in the Phoenix connectors, also known as Euro blocks or captive screw connectors, and a compatible Phoenix connector block provided with the digital signal processor. To use the microphone in external mute control mode, use a T10 screwdriver to remove the 3 screws found under the base of the microphone that secure the microphone grill. Lift off the grill and set both dip switches to the on position. Replace the microphone grill and move on to preparing the cable. Start by removing a portion of the outer jacket. We recommend approximately 6 inches in order to accommodate audio and control connections that are not located in close proximity. The CBL 301 provides a total of 11 conductors for making audio and control connections. Once the cable has been stripped back, the individual conductors must be terminated at the Phoenix connectors. The cable's audio ground can be connected to any of the shield connections of the analog inputs being used for the microphone. All audio shield connections on the DCP's analog inputs are internally connected and therefore are not required to jump the ground of all 3 channels of the CBL 301. Using one of the Phoenix connectors provided with the DCP, secure the audio ground and channel 1 hot and cold conductors. These are the red and orange wires respectively. Refer to the labeling on the back of the DSP if you're unsure of where to make connections for each channel. Continue with the purple and blue pair for channels 2 and finally the yellow and green pair for channel 3. The brown and black pair of conductors are used for the mute control signals. When operating the microphone in external mute control mode, the brown wire used for the mute I/O can be connected to any of the 16 general-purpose inputs, and the black wire used for the microphone's digital ground is then connected to one of the 2 common connections. When the microphone's touch ring is touched, the mute I/O will short to the digital ground and be communicated to the DSP. This will require both multiple Phoenix connector blocks provided with the DCP. Finally, the white and gray pair of conductors are used to communicate LED ring colors to the microphone. Depending on their values, the microphone's LED ring can either be off, red, green, or blue. These wires will be connected to the logic outputs 1 and 2 along the bottom row of control ports. We'll see how the mute and LED states can be configured in just a few moments. After verifying all wires are secure within their respective Phoenix connectors, push all connectors into place at the digital signal processor. Now we are ready to configure the DSP to operate with the microphone. If you haven't already, make the proper network connections and power on the unit. For this demonstration, we are going to just focus on configuring the DCP's mutes to react to a touch event at the microphone, and in turn control the microphone's LED ring. We will not worry about any other processing or routing. After logging into the DCP's web interface, we can open either a new or existing configuration. Within this configuration, we have already configured the first 3 channels for analog inputs 1 through 3. Now, with the CBL 301 configured for external mute control, any mute found within the DCP configurations can be enabled or disabled when a touch event takes place at the mic. We are just going to focus on the mutes found on channels 1 through 3 of the analog inputs. Let's move to the GPIO settings for the DCP. With GPI port 1 selected, we will choose Momentary Contact Closure. Then we can simply select which mute parameters we want to control. Finally, for the control setting, we have a few options. Close equals muted means as long as the ring is being touched, then the mutes will be activated. The moment it is released, the mutes will deactivate. This can be thought of as a push to mute. Setting it to close equals unmuted will result in the opposite behavior. Touching the ring will cause the mutes to be deactivated, and after releasing the ring, the mutes will revert to being activated. We can think of this as push to talk. Toggle action will cause the mute to alternate states based on momentarily shorting the mute I/O to the digital ground, and does not require the user to continuously touch the ring to activate or deactivate the mutes. This operation is similar to the default mode, and we'll just leave it set here. Multi-state mode is not applicable for this application. Finally, the microphone's LED ring color is determined by external control when using the microphone in external mute control mode. You'll recall we connected 2 wires to logic outputs 1 and 2. Depending on how we send a high or low voltage control signal across the 2 wires, we can determine the color of the ring. In this demonstration, we want the LED ring to be off as long as the mutes are deactivated, and the LED ring should be red if the mutes are activated. To accomplish this, we can simply assign the channel 1 mute to GPO port 1 and leave its invert control in the off position. When the mute is activated, only a high 5-volt voltage control signal will be sent across the white LED wire to the microphone. When deactivated, the LED ring will revert to an off state. This concludes our demonstration. For more info, please visit akg.com, and thanks for watching.